In this video we will demonstrate the new privacy tool Major Privacy. It is a successor to the old private Winton tool, which is no longer maintained. Its beta build is distributed as a zip archive, so we need to unpack it, and the driver is signed, but the other files are not. It also comes with a installation of imdisk, which will be required for the secure volumes feature later on. To start it, we start the Major Privacy exe, and it tells us that it will now start the privacy agent service, which will require administrative privileges. We quickly allow it those rights, and as soon as the UI is done loading the service, it can be used. Let's make it slightly bigger and see what we have there. So the first tab below the home page shows us a very standardized view. The same view is used on two other tabs, while the yet other tabs have individual views. The view is designed such that on the right hand side we have a tree of all the applications which have been found on the system, which includes also processes which are found in real time. So when we start Notepad 2, it added here the Notepad 2 exe to the already known installation. We can also in this view add own items. In this case we can either add application files which have not yet been found, or we can add folder templates. Let's say program files, C program files asterisk, and a new group program files has been created, and all the items which within the file system hierarchy fit into this group have been automatically added, like Microsoft Edge, Notepad 2 exe, all the user apps, and so on and so on. The filters like this one or this one can be deleted, the individual exes as well. Other items like Windows services and apps cannot, as they are found in the system and they're still present in the system. You would need to remove them from the system in order to get rid of them from this view. Another thing to note about this view is that it comes with a few predefined filters like Windows, system apps, user apps. Program files is not a predefined filter, system32 folder, and so on. Another important thing to keep in mind is, as we can see here, that Notepad now lives in two places, and the reason behind it is that the way this works, in pattern, a provided file pattern can match not uniquely something, so you can provide two different patterns which have no relation to each other, but both would in the end match the application. For example, we could add another pattern, notepads asterisk backslash notepad asterisk, so it will match everything that is a file and has a notepad in its name. In this case, notepads only matched our Notepad 2, but if we would start the Microsoft's built-in notepad, we would get yet another exe, which from its name would also fit this pattern, but Notepad, as we can see here at the end of the list at path, actually lives somewhere. Where is it? Notepad 2. It lives in a app folder, while the other notepad lives in program files. So as you see, this not unique attribution of elements to their parent groups is quite necessary. On the right hand side of these three views, we see the same design pattern. At the top there is place for rules. If we switch to firewall and select all programs, then we see all the Windows firewall rules as we are using the Windows firewall. Everything that is shown on the left hand side is only shown in relation to what is selected in the right hand tree. So if we select all programs, we see everything. If we collapse the tree, we also see everything. But if we select a more specific element, we only see rules which apply to this element and its child elements. Like in this case, for MS Edge, we only see the MS Edge rules. For program files, now we see only rules for elements which are stored under program files, and so on. On the bottom, we see collected informations about what is happening on the system, which are mostly based on collecting live data as well as recording a trace log or event log. Let's return to the process view. Here we have a list of all the running processes, if we select all programs, that is, obviously. And then we have other views which are all created from the trace log. The trace log contains all relevant events which the driver has recorded and sent to the privacy agent. But since such a log grows very quickly and is quite incomprehensible, we have these other views to help us understand what's happening. Let's select, for example, Microsoft Edge, and let's start Microsoft Edge, and let's close it again. And then let's see what the other views show us. The loaded modules view will show us the names of the programs which have been started from this group, and for each program it shows us which DLLs have been loaded and whether the operation was permitted or not. The next view, execution monitor, shows us what was started by what. So in this case, any action can be designated as target or actor. Here we see that MS Edge was target of being started. Started another instance of MS Edge, and it started a identity helper exe, and then it was a target of being started by Explorer exe, since we started it from Explorer. And then also here we have this elevation service, which Edge is using for updates, which has been started by the system service manager. So everything that's an actor acts on the element, and everything that's a target is being acted upon by this element. We can here use Ctrl F. Actually, we can use Ctrl F in any view to search for items. Let's here search for Explorer exe and see what the Explorer was doing. So Explorer started Edge and started Notepad++. We can start a few more things, and then we will get a few more events logged. As you see here, KeePass and our WinIO trigger all have been started and terminated now by Explorer exe. And the next one group here is called Ingress Monitor. It shows us which applications have interacted with our application. Let's go to an application which we have freshly started. Let's look for KeePass. Again, it is sorted into a few groups. We see KeePass was acted upon by Task Explorer, which, what did it do? It read its memory. This is necessary to find out the command line with which an application was started, but obviously could also be used to extract passwords from KeePass. Our privacy agent did the same. It wanted to know the command line. LSASS it's a part of Windows, and it's quite safe. It is a protected process, so we are not worried about it accessing it. Explorer used some duplicate handle access, which is on medium on the criticality scale. This tool is used for different alternative input methods, so it also accesses many things, and in fact we could block it. And then we have also CSRSS, which is an essential part of Windows, and it needs to have full access, and it will not be blocked even if we create a block rule, as it is itself a protected process with a higher privilege level. So we can first of all rely on it not being tampered with, and secondly it needs to be able to access our processes, otherwise they won't be able to start at all. So let's start and create a rule. Since we talked about KeePass, we can demonstrate how vulnerable it is. Let's add some secret. My secret password. I add a string so that I can quickly search for it. Obviously, a real attacker would understand KeePass's memory architecture and then would be able to find anything they want without having such a nice anchor to look for. So here we have our Task Explorer. Let's search for my secret. Zack. Did I call it my secret? Yeah. And as we see here, it found my secret password and the whole string, as well as many in between copies which have been stored in memory while I was typing. So obviously KeePass is in no way secure. An attacker on your system can access your open password manager. In principle, the way it works is if you run something under a not privileged user, anything else that runs under the same user can access it. So if you run KeePass as a user and as the same user run your browser, which gets compromised, the browser could access your KeePass and read all its memory. A privileged process running with administrative rights can even belong to any user. It can read and write memory of any other process. Same with system processes. So if a system service of Windows gets compromised, it has already full access to any process running on your system and is able to read its memory. The only exception here are protected processes, which Windows uses for some of its own internal components, and which functionality we here in Major Privacy replicate to add our own protected processes, where we can say what gets protected and what doesn't need to get protected. The system is completely independent from the Windows protected processes mechanism, hence it doesn't influence it. So everything that is protected by Windows stays this way, but we can add our own protection to processes which normally would not be protected. So let's exit KeePass here. Let's save the changes in our key database. Again, everything shown here is in relation to what we have selected. So here we don't see any rules. Obviously, we wouldn't see any even with all programs since we have not created any rules. But now let's create a rule for KeePass. Protect KeePass. We select KeePass here. It enters the right path, and then we can say what the rule should do. We have the choice between allow, block, and protect. Allow means it will allow the execution under the below signature requirements, but it will not implement any process protection. So the process will still have readable memory. This is of course useful to improve your security, but not that much useful to hide secrets. The next option, block, we can use if we just want some program not to be able to start on our system at all. Good examples would be some telemetry processes of Windows, or the software reporter tool exe from Chrome, which is snooping around in places it has no business of snooping around. So being able to prevent programs from starting just by specifying the path or a template to their path is quite useful. Of course, you have to be very careful. If you would specify to block the start of everything under C Windows, then your Windows will no longer be able to run. In the demo build, in the beta build here, the application does not auto start. So if you would set rules such that your system would become inoperable and crash, then after the reboot, just don't set the rules again, and you should be fine. But here for our KeePass, we select protect, which means it will protect the process, and then here we have a set of signature requirements. We will select user signature or trusted by Microsoft, which is the most reasonable option. The user plus Microsoft is pretty much just what you signed and what is part of Windows, and the top one is what you signed, which means it won't even want to run on Windows, since core Windows DLLs would not be properly signed, so you would need to sign all those files and after every Windows update re-sign it yourself. But since the user is the highest authority in every system, this should be offered as an option, even though its use is a bit more cumbersome. Any signature means it just has to be signed, but it does not specify that the signature has a trusted root, so it's not really safe. And of course there's the option no signature, in case you are just creating a block rule or just want an allow rule. Another thing to note here is that you could create a block rule for a given folder and then an allow rule which has a specified signature, such that everything without that signature will be blocked and everything that passes the signature will be allowed. You can specify allow rules with a higher specificity, like in Sandboxy Plus, where the more specialized a path is, the higher priority of the rule is. So this is all quite flexible. With the protect option chosen, here we have the last set of options to keep in mind. One is this image load protection. We want to set, of course, signature here to user and trusted. Image load protection means that the signature requirement does not only apply to the process itself, but also to the DLLs which it loads. If it's activated as it is here, all the DLLs need to be signed with the same signature level or higher as selected for the process. And the last group here, it determines what happens when the protected process tries to spawn a child process. On-trusted means if it tries to spawn a process at the same or higher signature level. On untrusted means what happens if it tries to start something which has a lower or no signature at all. The default is that if it's trusted, it allows the execution. The default for untrusted is it allows the execution, but it throws the process out of the secure enclave, meaning that the newly created process cannot communicate or access the parent secure process. We will keep this as is. and press OK, and here we have our rule. Now when we start KeePass, we got an error. The reason is KeePass is not signed in a way that would satisfy our signature requirements. We got here also a pop-up which offers us the opportunity to sign the file, but first we need to set up our own signature key. The key, if you use the option set up user key, will be automatically randomly generated and stored in an encrypted form in the registry. So we need to provide a password for this encryption. And now, since the key has been installed, we also see the key fingerprint in the title bar of the application. You can monitor the fingerprint in case if you see it changes, it means that some third-party application has replaced your key in registry. This is not possible as long as the application is running, as it protects its own registry key. But an attacker that has access to the unbooted system can of course modify the offline registry and then could change the key, which then you would notice through this fingerprint. Now, since we have the key, we can sign KeePass. For every operation that requires our key, we need to re-enter the password. In a later build, we will add a mechanism to cache the password such that you don't only need to enter it after it wasn't used for 5 minutes. Here, we also need to grant it admin permission, since we are moving a file to a program files location, which is only writable for administrators, and here the UI only runs as a user. So since we did this, now we should be able to start KeePass, and as you see, it is trying to load some DLLs, but this fails. So we will need to allow this DLLs as well. Let's see what we have here. We have the whole path of the DLL at the back. These are a couple of framework DLLs for Microsoft and a couple of DLLs from KeePass itself. Let's first sign those two. We can select multiple files. Well, no, we can only select opt to sign all of them. Here we only can select one by one, so let's go with one by one. And one other security consideration here is that here in the UI and the privacy service of Private Winton are both also treated as protected processes, so that the key in their memory cannot be exfiltrated by anything that runs on your system, be that with user, system, or administrative privileges. The only privilege level which can access protected processes is the kernel itself, and to get inside the Windows kernel, you need a signed driver or a known unpatched vulnerability. So this is as secure as it gets on Windows. Let's see now if we can start KeePass with those DLLs signed. Seems that was enough. The other DLLs are not necessary, so here we can just ignore to discard them. Open our KeePass again. Apparently it still tries to load yet another DLL which we have not yet signed. So since it's not a framework DLL but part of KeePass, let's sign it as well. Zack. Okay. And now obviously still we have here our secret, so let's see if we can find it. You can note that Task Explorer here runs with administrative privileges, which are for this application as good as it gets. What do we need to look for? My secret. So let's see, search. Well, it found something in this input tool for alternative inputs, but it was not able to access KeePass. So what we can do also is we can copy this cell. Here, look for the tool and make a block rule, or we could also protect it, but since we don't really need it, we can just create a block rule for this component. Here we don't need anything, and now we just need to terminate the tool, which we can do using Task Explorer. And unless you are using handwrite recognition or some alternative input methods, this will be quite fine. We can also here take a look what is trying, if anything is trying to restart this tool. Currently, apparently, there is no attempt of restarting it. An important thing to note is that what we see here is based mostly on the trace log. So obviously things that were started before the privacy agent and the driver were running is not known to the application. Now, since our KeePass is still running, we can take a look on the next tab. Here we see all the secure enclaves that are present in the system. the enclave number 1 always exists and contains the core components of major privacy, the UI and the privacy service. And here we have a enclave just created for KeePass, and this enclave will always contain only one application, since we configured our KeePass rule such that it will allow execution. So let's eject this as well. Now it won't contain anything, even if it's a trusted application. Also here we probably should give it a better name for this rule. In this field here you can specify some additional data, just a description. It's only for the user, it doesn't have any further meaning. Okay, so far so good. We know how to secure a tool like KeePass. Of course, the same applies for crypto wallets or other tools which in principle have encrypted data on disk, but when mounted and unlocked are fair game to anything that can read their memory, which on a Windows system is unfortunately a lot. So the next view here provides us file and folder protection. The first tab, all open resources, should show us all the open files. This is nice to see, but it causes some additional CPU load, so by default it's turned off. Here we will enable it, and then we see all the files that are open on the system. And likewise we have a trace log which contains all the file accesses on the system, which again is a lot. Such a trace log grows very quickly and is quite difficult to comprehend. One can of course search in it, but this is not the best option. Here henceforth we generate a view which extracts the data from the trace log and shows us in a tree structure which resources have been accessed. Again, here we have selected all programs, so it shows us quite a lot, but we could, for example, opt to only see what KeePass was doing, and then here we will see all the files and folders which KeePass has accessed. And here we see, of course, the KeePass database and so on and so on. We can select an entry, and then we see all the files in detail. This is also useful if we select an entry which contains more than one item, because then if we select something, we can see for every program a verbose list of which paths that one program has accessed. So the idea here is to empower the user to take control over their system and to understand what the programs which are running on their systems are doing. And of course, understanding is the first step to taking control. So we need to know what wants access what and what accesses things that it shouldn't. And once we know that, we can define rules. Also, we can define rules proactively. Let's say we create on our C drive a secret folder which will contain some secret data. My super secret text. Okay, again, Notepad is not protected, so maybe we should protect it. But also here, anything could read our secret folder. On Windows, we could set permissions such that only certain users can access that folder. But again, this won't really help against an attacker with administrative privileges. So we need a more radical approach, like a file system filter driver, which Major Privacy offers. So we create a file system rule. We call it protect secret folder, and then we specify our secret folder with an asterisk, since we want this to not just protect this one folder but all the subfolders and all the files inside. If we wouldn't give this asterisk here, the actual text file would be again accessible, so this needs to be remembered. And we can select which access we want to grant. Allow obviously means allow everything. Likewise with program rules here, if we specify more specific rules, then they take precedence over the less specific ones. We can allow read-only access, we can allow only directory listing, or we can choose between protect and block. Those are functionally identical, just that the protect option will pop up a window notifying us about the access attempt, while block will just always silently block the access. So here let's go with protect, and then we need to specify what this should apply for, and since we want this to apply to all programs, we just go with asterisk. We could also leave this empty for the same effect. And we select here all programs so that we see the newly created rule. So let's see. Now if we try to access the folder, we get an access denied, and here we see what Explorer tried to access. Even if we start a command line application with elevated privileges, we won't be able to access the content secret folder. Oops, dear. Access denied, so this works as expected. So first thing that would be useful, probably we would want to use Explorer to browse the folder. Since the secrets are inside the files and the file names themselves are not so super secret, let's select the secret folder and allow it directory listing. And the rest we ignore. So now we can open it and we can see what's inside, but we cannot open it. So first of all, let's create here again a rule, a full access rule for Notepad that allows it to access this location. And in addition, we probably want to create here for our Notepad 2 a protection rule such that our Notepad will be protected. We leave the rest at the default presets. We should give it a name, protect Notepad, and we will run into the same scenario as before. When we try to run it, it first needs to be signed by us, since this is a third-party Notepad replacement. It is not sufficiently high level signed, but as soon as we have signed it ourselves, it can run. Note here that when I'm talking about signing, we are not actually signing the file in the way a file is normally signed, by attaching data to it, but instead we are creating a secondary file with the same name as the binary, just with the SIG extension, and the driver is looking for that file. So all these signature operations that you are doing here are not changing even a single byte in your original files. They are just adding these new signature files in addition to your file system. Okay, so at this point we can already feel quite safe. So nothing can read our super secret data except Notepad, and Notepad is protected. It runs, as you can see, in a secure enclave like KeePass. But unfortunately, this is not the whole story, since while the file cannot be accessed and the file system driver filters the access, something with administrative privileges can read the raw disk and then interpret the file system table and access our super secret file. For example, here is a tool that can do that. We can run it as administrator. Let's quickly close that. Open the disk, number C, drive letter C. It will need a second to read the whole file system, but as soon as it is done reading the file system, it will be able to show us everything: the secret folder and the secret and the super secret text in it. So as you see, the protection is yet not complete. It's good enough for things that store things in an encrypted way on the hard disk, but it is not good enough against an attacker with administrative or system privileges whom is reading the raw drive. So let's exit this, and now let's see how we solve that issue. We simply go to the next step, which will allow us to create an encrypted volume. We are using the same mechanism as Sandboxy Plus is using for its encrypted sandboxes. So first we need to install the imdisk driver such that it can be mounted. In a later build, this functionality might be added directly so that no third-party driver will be needed, but for now we are using this method. The file format is the same as Sandboxy uses it, which is a encrypted container using the descriptor encryption algorithms and implementations. So it's usually ACE with XDS as operation mode. So we have installed our imdisk driver. So now let's create a secure volume. Let's create it at C. At C test, or let's just go for C direct or for temp, wherever we want it. We also could create under our document, but well, let's go with temp. Create volume, private volume, as is the chosen file extension. Now let's specify some super secret password, and as soon as it is done creating the volume and formatting it, it will show it in this list. This will take a second. We also get the obligatory warning that if you lose your data, it's on your own responsibility. We don't take responsibility for anything. Have a backup at hand always. Okay, so we have here the volume. We can mount it. 1, 2, 3. We can then go to it. It's the drive letter E. Create here a data folder on which we create some secret file. super secret data. At this level, at this point, it is just a normal encrypted volume. It's not yet protected, so we shouldn't put. So first we should have set up the protection, and then start putting protected data on it. In principle, you could also use a volume created by VeraCrypt, but then you would be missing the nice integration here. So let's quickly unmount it. Let's copy. Once that mount is done, we can copy here the full file path, and then we go back to our rules. We create. Let's go for all programs. We create here a new rule. Protect. Give it a name, protect volume, and as a path to protect, we specify the protect volume and then /*. This / means that this rule will be applied to the actual device where this volume is mounted. We don't know where it will be mounted, but once it's mounted, this rule will be updated accordingly. A copy of this rule will be created for this application. We'll see those rules here, and then of course we want protect, and for all programs. Then let's also add a explorer volume. Here we select allow /*, not allow, we want directory listing only, and here we would need to look for Windows Explorer. That might take a while. Let's just type the path. That should be faster. Okay, directory listing is allowed. That's all we want for now. We see here the path and here the application. So let's mount the volume again. This time it will be protected. Zack. And when we switch back to the view, you see here two new temporary rules generated, marked in italic text, and they are protecting the AIM disk volume 0. Also, we can now here see some notifications. We will discard them for now, and we should be of course able to browse it, but then again Notepad won't be able to access it since we have not made an access rule for Notepad. Let's create it. Click, ignore, and then we can see here that the rule was created. The rule creation wizard automatically selected the right volume, so it knew that the rule should not apply to the drive letter E, but it should apply to whichever drive letter the volume becomes, and in real time a new temporary rule for this actual device has been created. So now we can access it with Notepad. Again, it seems Notepad tries to access the root, which here we block, but this we could also ignore it or add it to an ignore list if we want. For now, let's just ignore this one event, and now let's see what our disk editor will say. Right, we need to restart it with admin rights, of course. Zack. And keep in mind that it is like showing us the old content of the disk. So let's open the disk again and read it fully, so not using some old snapshot. And again, here we get an access denied and a log that the application, here this WinHex, tried to access the volume E, which we didn't want it to be able to access. So now, at this point, one could say you don't even need a password manager. You could just keep a text file on a protected volume, and it would be just as safe as a password manager. It would be, of course, a bit more cumbersome, since the whole volume is much bigger and it adds additional overhead. But functionally, the thing is equivalent. The data are encrypted. They can only be accessed once they are decrypted, and the things that can access those data and that decrypted data are themselves protected, such that nothing except the Windows kernel can read their memory. Okay, good. So this view will later be updated such that you could directly from this view manage rules for your secure volumes, but for now this is just a simple view. The UI will be extended a lot in future builds of this tool. So especially there will be a lot of quality of life improvements, like a lot of view filters and stuff like that, which will be quite useful. Right, the next step is more or less doing the same as in the private Winten predecessor tool. It just shows you all the Windows firewall rules, open sockets, at the connection log, and here in the traffic monitor you have a collection of all the IP addresses and domains which have been accessed by the different applications, such that we know what tried to access what. This is much more comprehensible than just a long log. The log, by the way, also is limited to only 1000 entries, so that it will not consume too much memory. But this information here, which are extracted from the log in real time, are kept for as long as the service is running, so that you can inspect what was happening. An important thing to notice, of course, that as soon as you shut down this portable edition, it will also unload the driver, which means all the protection will be gone. So you only should shut down the tool once you have closed all the applications which you want to be protected. The next view shows a list of all the DNS entries in the current DNS cache. Later, he will add a Pi-hole style DNS filter like it is present in private Winten. But for now, since this is not a very commonly used feature, we only added here the very basics to view the current DNS cache. And on the last tab, we have all the tweaks that also private Winten is offering. So, for example, to disable telemetry in a very far away, or here or there, and so on. The old private Winten had the functionality to block individual files from execution by changing their file system permissions. Now you can achieve the same goal in a much more reliable way by simply creating a rule, for example, block compat.tel runner exe. This file is somewhere on the C drive. We could also specify the full path. Let's see if we can, if Windows search actually, Windows search obviously is not good. I actually found something, but let's go to the right path. And find it. Compat.tel runner, this one we don't like. Just copy the file name and the full path. And now we create a block rule for compat.tel runner, so that what's here supersedes whatever is selected from the drop-down block. We don't care for the signature. And now this application won't be able to start on our system anymore. You can do the same with Chrome Software Reporter exe and other tools which are used for telemetry or which you don't want to run on your system. This concludes the demonstration of the application. A lot of feedback would be welcome. You can download the version from GitHub and test it yourself. As mentioned already, if you create some rules which would break your operating system, then those rules will not be auto-applied on the next start of your computer, so you have the opportunity to delete all the data and then reset your application and try again. I will release a few more videos demonstrating other functionality. There is maybe one thing we should demonstrate here now before we finish. That is this process protection light feature, which does not use a secure enclave, but which prevents protected programs from loading untrusted DLLs. So let's again stay in this window and look for Explorer exe. As you can see, we have installed quite a few shell extensions. So we have 7-zip, and here we have something else that works with system links. It shows us some additional icons, and if we go to properties, it will also show us link properties. So Explorer currently loads some non-trusted DLLs. Also here, our third-party start menu is also one of those untrusted things. So if you want to protect your Explorer from loading untrusted code, we can create a rule. Secure Explorer. We select Explorer. in action we select only allow, because we don't want Explorer to run in a secure enclave. We only want it to not be allowed to load untrusted DLLs. Here we let this at the default. Here this doesn't matter as long as we don't select protection. Of course, image load protection must be selected. So let's apply the rule. Now, of course, Explorer is not yet protected, so we need to restart it. And now when we start Explorer, it will actually fail to start because it tries to load this start menu helper DLL, which is not signed. So we quickly sign it. Zack. And now it will start. And as we see, it wants another helper DLL. So the first DLL is facilitating the loading, and the next DLL is actually implementing the start menu. So now we have the Windows 11 start menu back. So here we just sign this file as well. And since the loader DLL, which we already signed before, is kind of permanently reattempting to load our DLL, it now got loaded. Some other extensions might need Explorer to restart again to be loaded properly. But when we open the file browser, we see here that this hardlink extension and the 7-zip extension, both DLLs could not be loaded since they are not signed. And if we select something here, a file, we don't see the 7-zip extension anymore. Also here, when we click on those, we don't see this additional information window tab that was provided by this hardlink extension. If we want them back, for example, we want 7-zip back, we can just sign 7-zip. And I think we don't even need to restart Explorer since we already saw a few load attempts. So if we click here, it loaded 7-zip successful. So now we're only missing this hardlink extension. So let's sign this as well. Obviously, if you want to be really safe, you should first check whether you really trust whomever made those tools. In case of 7-zip, I think this is quite safe. The other hardlink thing, I don't know for sure, but it looks useful. So here again, we have our Link-Eigenschaften. So as you see, in principle, you could use such a mechanism to protect any application you want, not just Explorer, from loading untrusted DLLs without going the full route of protecting it fully. So as you see here, while Notepad and KeePass and our components are run securely, the Explorer itself is not shown here as being run in a secure enclave. If we select it and look here, we see however that it says status protected, but the security is only minimal. If we select all programs, things which are fully protected in enclaves are shown in bold, so like Notepad, here the components of our major privacy, and we should have KeePass somewhere here. While Explorer as such is not protected, but at least it has some protection status, as we can see here. And I think at this point it is a good time to finish the demonstration. We don't want this video to be too long. So if you have any questions, you can ask them in our forums or on GitHub, and you can find this release on GitHub so that you can test it yourself and see how it can improve your own privacy. Thank you for your attention.